Hello everyone, welcome to Module 3 of DSCI 300. In this module, we'll introduce the third tool, simulation. First of all, why simulation? Well, every tool has its own strength and weakness. We have learned linear programming and decision analysis so far. They are great tools, but they also have their limitations. For example, let's say you're designing the layout of a warehouse for whatever objective. Can you use any of the tools we learned so far to find out the best layout? I guess you probably would say not. And why? There are many reasons. First of all, it's hard to mathematically describe the movement of people. It's really mathematically challenging to describe the interaction between people and the products or the goods. The dynamics are so complicated to be mathematically described. Anyway, it's not hard to see the challenges. Compared to other tools we have introduced, the biggest strength of simulation is that it really allows you to describe a complex system like this. So what does simulation do? Simulation basically tries to replicate the features, appearance, and characteristics of a real system. You probably have seen simulation in other courses. If not, you may have seen video games like Flight Simulator or Call of Duty. These video games are good examples of simulation for entertainment. By the way, don't worry if you have no idea about these games. You will not be tested on this in the exam. But anyway, when do we prefer to build a simulation model over using other tools? Well, basically, you prefer to use simulation when there are many uncertainties you need to consider or the dynamics are too complicated to mathematically describe, or when you are okay with a reasonably good solution instead of pursuing the so-called optimal solution. The reason I say reasonably good solution is because simulation does not necessarily give you the so-called optimal solution. Simulation basically numerically evaluates the performance of the system it mimics with the given parameters and specific choice of actions. For example, let's say you have a simulation model for a company's profit. You tell the model the retail price of a product and the model will tell you the resulting profit. You give it different prices and the model would give you different profits. That's it. The model wouldn't really tell you what is the best price to set. If your goal is to maximize the profit, then you will simply try out different prices and see which price gives you the highest profit. So in other words, simulation is a trial and error approach to identify the best decisions. In this course, we will learn how to build simulation models in Excel. Our goal is to introduce the fundamental concepts of simulation to you, so that if you have a chance to use other much more powerful simulation tools, you know what's happening under the hood. Also, you will see Excel is really capable of making many practically useful simulation. One of the fundamental engines for simulation is to replicate the uncertainty through their probabilities. For example, let's say you want to simulate the result of flipping a coin. You know the possible outcomes are head or tail, and these outcomes have 50-50 chance to occur. To simulate this, all you need to do is to have some kind of mechanism that can generate two possible outcomes with equal probabilities. The challenge in most real cases is how do we get the probabilities for the possible outcomes? The probability for the possible outcomes is called a probability distribution. One of the ways to obtain it is through historical or empirical data. We can describe the process from data to simulation in this roadmap. First, you collect data. You have data. Then you can use the data to find out the probability distribution of an uncertainty. Then you can feed this uncertainty into a simulation model to simulate whatever you try to simulate. Well, let me give you an example. Let's say we want to use a simulation model to find out the chance of selling at least 20 iPads in a day at a store. Apparently, the daily demand for iPads is uncertain. Stores usually have sales records. So we can use the historical sales data to construct the probability distribution of the iPad demand. For example, maybe from the data we find that the store sells 10 iPads in a day 30% of the time. Maybe it sells 20 iPads in a day 40% of the time, and so on and so forth. Then we can build a simulation model that simulates the demand for, let's say, 1,000 simulated days. Then we run the stats on the simulated demand, and we find that, let's say, 69% of the simulated days sell at least 20 iPads. This roadmap is very important because this is exactly the process that I will take you through. And I hope the iPad example can give you a picture on what we will do.